Hello, everyone. Okay, great. Okay, great. So, topic for today will be first getting serious about privacy, and so we'll talk first a little bit about Ethereum, the approach that I've been thinking about in terms of how Ethereum can move forward on privacy, what kinds of things we should do, in what order, what kinds of things we should do that we have not been thinking about before so far, and what kinds of things we should not do. And then we'll be very happy to take and answer any kind of questions from you. So I think what we've seen so far is that Ethereum has led the way on privacy research and development in a lot of different ways, right? So Zcash, of course, was the first major production implementation of on-chain privacy, and I think systems on Ethereum were probably either the second or close to the second. So back in 2019, we had the EC mull and EC add and EC pairing opcodes that enabled all kinds of on-chain privacy solutions to start happening. And then we saw Tornado Cash, and Tornado Cash launched on Ethereum, and Ethereum was the chain where the entire arc of that very complicated story happened. By the way, free Roman Storm continues to need help. Then PSC, the privacy scaling explorations in the Ethereum Foundation, they have worked on many kinds of ZK snark protocols, a lot of low-level protocol-related research, a lot of dev tooling-related work, a lot of implementation level work. PSC has been a bedrock of a lot of like very bottom-level tooling and ideas on zero-knowledge proofs for scaling and zero-knowledge proofs for privacy. Also, L2s have contributed a lot. So Aztec, in addition to releasing, I think, already multiple test versions, and I believe mainnet coming soon, has also been experimenting with a lot of very innovative ideas regarding privacy, but also things, lower-level things like the Noir language, also the entire Plonk and Plookup category of algorithms. Also IntMax, fully ZK snark-based plasma rollup hybrid. Nightfall from EY, championed by Paul Brody quite a bit. So Ethereum has been a home for a huge amount of valuable privacy-related work, right? But the problem is that on real-world value delivered to users, we are far behind where we could be. So if you use actually using a privacy protocols on Ethereum today, who here has used a privacy protocol on Ethereum in this month? Who here has used Railway? Privacy pools? Tornado Cash? Something different from all three? Shout them out? Monero, okay. Bao, okay. Portisha, okay. Now, see, a lot of things are starting to happen, but what does using a privacy protocol today look like, right? So my experience is, so one, it requires you to have a separate seed phrase, and so you have this like totally separate thing that you have to worry about holding and not losing and not having stolen if you want to use your assets. That's one. Two is there's no multisig option. The only option is a single key option, which is like pretty scary for large amounts of funds. Three, it requires opening a separate wallet. So whenever you want to do a private send, you have to go and like open the thing, and then it like slowly starts loading. It goes from 0 to 100. You have to wait like 30 seconds. Four, you need a total of about 5 clicks to private send and withdraw. So I think when I use Railway, I count, click 1, open the Railway wallet, and then click 2, you have to click on unshield, which is like a different thing than send. And like the thing that I think of as sending is actually unshielding. Sometimes I click send and then I realize that's the wrong thing, and I have to do a third click of clicking unshield. But anyway. 2, click on shield, then 3, click on generate proof, then you wait, then 4, click on choosing a public broadcaster, and then like when And then when the proof is done, usually like a fifth click to actually start the whole process, right? So it's much complicated just on a raw UX level than it could be. And also the public broadcaster mechanism, this is something common to Tornado Cash and Railway and any one of these systems that tries to actually be decentralized. These things are brittle, these things often break. These things, within the last 6 months, I've had situations where it just broke completely on one version and I had to switch versions. At some point it broke completely on one internet connection. I had to either turn a VPN on or turn a VPN off. So very far from perfect, and we can do better. So why now, right? Why do we want to really push for privacy now as opposed to pushing for privacy in, say, either 2021 or 2029, right? So I think, first of all, at the top of all this, privacy is important, right? Privacy is freedom, privacy is order, privacy is progress, privacy is a bedrock of a lot of things that we care about in this world. Privacy is not just an abstraction in the same way that something like decentralization or credible neutrality is. Privacy is a concrete benefit that is directly appealing to users. It's you can understand what it means to transact privately, and transacting privately as opposed to transacting publicly is something that actually has meaningful differences in the kind of experience you will have during the transaction, but more importantly, after the transaction, right? Freedom of speech is easy, freedom after speech is the harder thing. Also, the technology is mature enough today. This was not true 4 years ago. And so today we can do it, and therefore we must. So the way that I think about privacy on Ethereum is I break it up into 3 categories. So I think of privacy of rights on-chain. So basically when you perform operations, things like sending, those operations happen on-chain. By default, everything you do on-chain creates a public link between every operation and every other operation. How do we do with these things without creating the on-chain public link? Then number 2, privacy of rights off-chain. In this case, how do you avoid leaking information when you're sending transactions, like basically all the parts other than the blockchain itself? And number 3, privacy of reads, right? When you read the chain, then reading the chain also reveals a lot of things about who you are and what you're doing, and how do we actually try to minimize that? So let's start with privacy of rights. 3 categories that I think we can focus on short term. 1 is funds transfers, 2 is DeFi, 3 is voting. These are basic category of operations, and there are strong cases to have privacy for each of these. So private funds transfers, I think we all know about. Private DeFi, so Railway, for example, has private DeFi inside of it. Adding privacy to DeFi has a value in a lot of different ways. It's valuable for people not to know what your investments are, what your strategies are. It's valuable for people to not know what your liquidation price is. It's valuable for people to not know everything you're doing in real time so that they can front run you. There's all kinds of reasons why it's important to be private in DeFi in order to protect you. And also having private DeFi increases the amount of funds that people are willing to store in a private context, which in turn makes it more viable to make private transactions. Privacy in voting, also super important. Projects like Macy are moving forward, starting to actually get used more. Also, other forms of ZK voting already exist and are already increasing in their user friendliness and their integration. So without privacy, voting turns into a very toxic social game, and so we need to really make privacy in any kind of on-chain voting a reality and the default. And then the holy grail, of course, is to have privacy of general computation. Privacy of general computation is hard for a bunch of reasons. One of those reasons is that general computation involves doing a VM, and VMs involve client-side proving, and client-side proving is even harder to make efficient than server-side proving. And another reason is that privacy in a general purpose way requires rethinking the software development model, because you don't just think about who owns what assets, you have to also think about who has access to what pieces of data. And things like what Aztec has been doing in terms of figuring out like Noir and figuring out their entire account and contract model, like it's actually a pretty intricate and challenging amount of work, but ultimately this is the holy grail. Privacy of rights off-chain. Okay, basically, this one's actually the easy one. So basically, the thing that matters here is send raw transaction as well as the various equivalents for ERC 4337 for intent-based transfers, like 7683 for like every type of send, needs to be able to happen through a mixnet, so that when you do these operations, there is not a public link between your IP address and the transaction. We should not expect that the Ethereum network is private by default. We should expect that people who want to see things are going to run like 30% of the nodes in the network just so that they can see everything that's going on, and the demand for this to increase as on-chain data leakage decreases, and so we need to increase the amount of network layer privacy as well. Now, privacy of reads is something that I think we have not been talking about nearly enough, right? So, who here has been using, raise your hands again, has used an on-chain privacy protocol this month? Who here thinks you were private? Okay, good. So basically, chances are you leaked everything about yourself to whatever RPC provider you're using. This is a problem, and this is a problem that can be fixed. So I see two tracks for solving this. So one of them is keeping the form factor of a small light client connecting to a large RPC server, but making that connection actually be private. So we've been thinking about making light client connections secure for a long time. I've been talking about Helios for a long time. Noah Cintron has been heroically working on Helios for a long time. What Helios does not do is it gives you light client security. It does not give you any kind of privacy. And actually, a lot of the time, the more harmful thing that an RPC can do to you is not feed you bad information, even though feeding you bad information can totally cause you to lose huge amounts of money in a DEX. Rather, it's stealing your information and then potentially selling it off and like potentially sending it out who knows where else. And so the idea here is basically we use cryptographic technologies in order to make it possible for people to ask RPC servers for information, get back responses, without the RPC servers even knowing what they answered. So there's a short-term approach which uses trusted execution environments together with oblivious RAM, basically using like these trusted hardware-based security models to reduce the opportunities for data leakage. And ORAM basically makes the TEE problem easier because you don't have to worry about leaking memory access patterns. Instead, the thing that has to be private is basically just a much smaller thing that has like basically O of 1 memory in it. But then, of course, hardware-based security models are very imperfect, and there is a more holy grail-y solution, which is private information retrieval, PIR. So this thing has a lot of challenges in terms of efficiency, but the efficiency of PIR has been improving more and more with every passing year, and it is something that I think we actually can get to doing. So making hardened RPC nodes is one of these paths. The other one of these paths is making it easier and more practical for a user to run their own node, even as Ethereum L1 scales. So who here runs their own node or has run their own node in the last 12 months? Okay, someone shout out how many gigabytes it takes on your hard drive. A few hundred? Okay. Someone else shout out how many gigabytes do you have on your hard drive? Anyone shout out their number? I mean, mine is like 2048, but I got a fancy laptop to play around with self-hosted LLMs. Okay, who here has on the hard drive of their laptop more than 256 gigs of disk space? Raise your hand if you have more. Okay, more than 512. Okay, so actually see now in the the EIP over 9,000, I forget the exact number, in the proposed EIP that specifies Ethereum node requirements, the expected amount of disk space is 4 terabytes. So who here has 4 terabytes? Okay, one hand is up. Great. Now, this is a problem, right? And so I think there actually is a pathway to make the node running requirements decrease massively. And that pathway basically is 1, history expiry, make it so that nodes do not have to store history. And then if you even only do that, and then 2 is you do things like block level access list and ZK EVMs. And so you basically get verified blocks, and the only thing that you have to track is the state itself, and then you just get fed verified deltas to the state. You can apply the deltas directly. Then that can reduce, even today, a node's storage requirements to something like 50 to 80 gigabytes. So who here on their laptop has, let's say, at least 80 gigabytes of space? Who here has that on their phone? Okay, so we, with today's numbers, we can actually make state storing nodes pretty viable. Now, of course, the argument is, well, what happens if L1 scales by 10x? Then within a few years, we expect that to increase back to the hundreds of gigabytes. And so the solution here is partial state nodes, basically nodes that only store parts of the state, and we need to figure out some kind of way of basically splitting apart parts of the state that are spam for parts of the state that are relevant to important applications, and then you as a user can store only those parts of the state, and if you make queries that touch only those parts, then nobody outside of you and your computer actually needs to find out anything about what reads you're making. So this is another piece of privacy of reads. A third piece of privacy of reads is identity and accounts, right? So who here has used ZK email? Anon, Har, any of the ZK wrappers? Okay. Who here has a world ID? Okay. Yeah, I mean, I agree. I hope the world goes to hell as well. Okay. Then, I mean, I had one and I lost it. Again, so, hopefully their recovery, yeah. Well, now, who here has used ZK Passport? Okay. I mean, actually, I have two, right? So, one of the parts of this, right? So basically, what is identity used for, right? I think identity is an important piece in all kinds of different applications. It can be used to prove that you are the same person that previously did some action. It can be used to prove that you're not a robot. It can be used to prove that you are a member of some community. But at the same time, identity has all kinds of risks if it's done incorrectly. So single global identifiers are something that could be abused for deplatforming, especially if they're not implemented well. If you have a single global identifier, even if everything is done through nullifiers, you can still be coerced into revealing your nullifier. So a lot of challenges in getting into this whole space and doing it well. And I think this is something where the world is moving forward into these kinds of things, and I think our community might be the most well-positioned to actually figure out a well-designed, privacy-friendly, and pluralistic form of identity, and reduce the chance that the thing that the world standardizes on is just terrible across multiple dimensions. Also, privacy of ID is something that directly comes into wallets themselves. So private account abstraction, right? So right now, to use Railway or to use privacy pools or any of these, you need to have one single key. Who here would feel comfortable trusting one single key with $1 million? Okay. $10 million. Okay. Let me ask the question another way. More than 10% of your assets. Okay, more than 50% of your assets. Okay, see, very few hands raised, right? And so basically, for privacy to be viable, we need the underlying accounts to actually be much more secure than single keys. So the most very basic thing you can do is, of course, multisig, right? But the real long-term thing that we can do is private account abstraction, right? Basically, whatever your normal account is, the account that you use to send normal transactions, in order to spend from private accounts that are ZK linked to that account, you have to provide a zero-knowledge proof that you still control that account. And then on top of that, you have to reveal that you control some extra secret, and the point of that extra secret is just the privacy part. So if we do this, then we can make ZK accounts much more secure. We can basically enable much more secure and zero-knowledge ways of revealing who you are, both to your on-chain account and to all kinds of other on-chain applications. And we can make this work seamlessly with your existing accounts on Ethereum. So, next. Yeah, so this is kind of my general privacy mind map. There are other important things to think about here, right? So one of those things is when do we get into doing privacy on the L1? I think this is a topic worth exploring. I think the reason to not do this literally tomorrow is basically that if you implement that and there is a bug in the privacy mechanism, then someone can print infinite money and you won't even be able to tell. So it's like pretty scary in that sense. So personally, I think we should wait until our privacy stack is and our ZK stack is like formally verified, proven to a much greater extent. And ideally, we can do that for the ZK that we use to scale Ethereum and for the ZK that we use to make Ethereum private at the same time. Also, ZK snarks on their own are not enough for a lot of things. There are things that require FHE. There are, though even with FHE, you need to have like basically a multisig backdoor committee that reveals when things get decrypted, which is like scary in its own way. I mean, for me, the holy grail is obfuscation. Maybe we actually might get obfuscation in the not too long-term future. Maybe we'll see. And so there's things that are worth thinking about in terms of like the Ethereum of 2040 from that point of view. So I think it's a discussion that we should consider. My view on short-term things the L1 should do for privacy is basically that whatever we do in terms of L1 account abstraction and L1 fossil support should be designed with privacy protocols in mind. And I think that's like the basic bottom line that we should agree on in terms of what L1 does for privacy in the short and medium term, at least until we're confident enough in the cryptography to actually stick privacy features into the L1 directly. So, conclusion, basically, privacy on Ethereum is happening, and there are already things that are underway on each of the items that I talked about. And I think anyone who is here can actually help build out any part of that map, right? So basically, go back one slide. So if any one of these bubbles, like any one of these things are things that people in this room can go and contribute to. If you are someone who is good at hacking around Ethereum clients, you can go build a partial state node. If you're someone who is good at figuring out private account abstraction and some of the like challenges around like doing on-chain reads and doing the client-side proving, you can work on that. Working on client-side proving enables a lot of these, so client-side proving work is important. Privacy-preserving voting is important. Each and every one of these items here are potential hackathon projects and are potential long-term projects for people here to put a lot of effort and time in. So let's work together. Let's make the best privacy-preserving user experience on Ethereum possible. So thank you, and happy to take questions.
We will have a Q&A session for half an hour. Please raise your questions if you have urgent questions now. Please.
Yeah, I have a question. Like, I think one of the best ways to preserve privacy is to do local and private first.
Mm-hmm.
And like, do you know, like we have been working on off-chain protocol to turn every file into a hash tree,
Mm-hmm.
which you can sign and attest, like timestamp and link into other files as well.
Mm-hmm.
Is there something similar you already know, which has been established?
Sorry, what use case is this for?
For example, you have private data, like you have a self-issued identity claim,
Mm-hmm.
and you want to attest it between friends, for example,
Mm-hmm.
and then you can have additional signatures which attest it to a key which has some form of public reputation.
Mm-hmm.
So you can issue your own identities
Yep.
off-chain, and you can use them to sign documents, for example.
Yeah.
I support this. I generally support a maximally off-chain approach because maximally off-chain means minimum metadata leakage, and I think it should be as easy as possible to make proofs over on-chain state and then combine that together with proofs over any kind of records that you have and be able to prove things about yourself without the chain or third parties learning about it. I think so. I mean, yes, I think that's super valuable. I mean, I think in order to have like a proper integrated pipeline that delivers these kinds of things, I think the like ZK Ethereum ecosystem probably does need to be a couple of steps more mature. Like it needs to be more viable to make a state proof of your own account. It needs to be more viable to just like make proofs that go into Ethereum state in general. But I'm sure these things will improve.
How would you explain what a nullifier is and why can it be coerced easily?
Okay, so the way that the math works, right, is that you have a secret, and then using that secret, you can like think of it as you hash the secret +1, and then you get a public number, and then you hash the secret +2, and then you get your nullifier. And so what you do is if you have like some resource that can only be spent once, then when you receive the resource, you publish the first number. And then when you spend it, you publish the second number along with a proof that there exists some first number that someone published previously where that like basically the same secret was used to generate both, right? And because the secret always stays private to you permanently, you're the only one that's able to make the proof. You're the only one that's ever able to actually know that link. And so what this means is that essentially, you're able to make a proof that says, I'm allowed to take this action because I have a resource of a particular type. And this proof, at the same time, like the nullifier being published, basically prevents you from claiming the resource twice. So it prevents you from DOSing the system. Now, the issue with coercion is basically that like someone can always, if they see that there is any action and that action is connected to you, then which they could find out like offline or through any other way, then they know that you are a user of this system, and they can force you to reveal your secret. And I mean, potentially they can like torture you or lock you up until you actually reveal the secret that maps to that nullifier. And then once you do that, then that also reveals your original leaf value, and then potentially that reveals your entire history, right? So these are the kinds of issues that like ZK by itself, and like especially ZK identity, because it creates this persistent object that you end up creating like many application-specific nullifiers from, right, needs to solve for, right? Because if you don't, then like someone can basically kind of force you to reveal your entire identity that you used to sign everything.
Do you have an opinion on the EIP 7503 wormholes? And do you think there's like plausible deniability and privacy possible?
Yeah, I mean, I think it's cool. I mean, I saw there were some recent improvements to it. I mean, things like making it work off of receipts instead of state proofs, which I think really improves the simplicity, reduces code complexity, which is good. I think for me personally to feel comfortable with it, the main blocker is basically that like ZK technology needs to get mature enough. And like it needs to get to the point where we have really, really strong assurance that this kind of thing is not going to be broken, right? Because if someone breaks it, they can, like they actually can print basically an unlimited amount of money, right? Like because the size of the anonymity set, like it's not even the set of all like explicit depositors, it's basically the set of all people who have transferred ETH into accounts where it has not been spent from. And so it's someone could just like print tens of millions of ETH before we know what's going wrong, right? So like being really solid on security is like the big prerequisite for me. I mean, there's also like smaller things like the fact like the 80 bytes kind of thing, and like the fact that even with the grinding it only has 92 bits of collision security, which is like, I mean, it's like, on the boundary of like being okay. I mean, I think if we're gonna take time to be confident on security, we should also take time to like maybe figure out how to finally move away from 20 byte addresses. So I think like some like security related things need to be figured out. I mean, personally, if the security related things were already solved, like I would totally love it and like want it to be in ASAP. But I think it will take time, and at some point we'll get to the point where we're comfortable with things like that.
You mentioned that you want to see our privacy tech stack formally verified. Obviously, formal verification comes in many formats. Can you talk just of what you would like to see under what paradigm to give you the confidence in the tech stack?
Yeah, so I mean, one analogy is like the way that we're approaching formal verification of the ZK EVM, right? And there's two aspects to it. One is formally verifying the arithmetization. So basically, this creates a machine verifiable proof of the mathematical statement that if you have a valid witness, like valid polynomial values for these polynomials, then that means that you have a valid execution of the underlying VM. That's like, and some implementation of that in Lean where the like final state is some particular value, right? And then on top of that, you can even prove other statements. So like, for example, there are some ZK VMs that have already proven a property called determinism, which basically means that the ZK EVM accepts exactly one post-state root. And so that's powerful because it means that like there aren't bugs that allow an attacker to just prove anything. So once you have, and then another part of the proof is like actually proving the kind of correctness of the proof systems themselves, right? And like that's something that I think we've gone into less because we're still in the arc of optimizing the proof systems, but at some point we need to start doing that. So that's the basic thing. Then similar types of things can be done for client-side proving, right? And so we can, like potentially, you can even convert statements like if you put one coin into Railway, then you can take one coin out into a mathematical statement that you can actually verify end-to-end, right? Or you can do similar things to virtual machine execution, right? So if we do things like that, then like we can get more comfortable with the actual safety of all of this zero-knowledge machinery that in the future millions of ETH will be dependent on.
Do you agree with the Ethereum community's reaction to the ban of tornado cash some years ago? And if not, how do you prevent it in the future?
I mean, to you, what was the Ethereum community's reaction to the tornado cash ban?
Well, I thought that many node runners started to censor transactions, and also I don't know if there was public support for developers of tornado cash and they go to jail.
Yeah. Yes. So, I mean, there was definitely a scare back in about 2022 to 2023 regarding block builder censorship, right? And this is like an intersection of the privacy legal issues and the whole like builder centralization problem. So my view on the builder centralization problem right now is that like we need Fossil as a way of mitigating it. Like basically what Fossil does is it creates 16 different actors per slot who have the power to force any particular transaction to get included inside of that slot. And so we get like very strong censorship resistance even if the entire block building market gets monopolized by one actor. Like not saying we should let that happen. happen, right? But even if, as a second layer of defense. I know there are people who are working on multi-party block building technologies, like basically market designs where blocks get built through the collaboration of multiple actors by default. And if that happens, that also helps kind of decrease the risk of single block builder dominance. So I think to me, like, that's strategy 2. And strategy 3 is like, I think we should at least explore some kind of encrypted mempool ideas in parallel. So, like, to me, those are the top 3, and I think if privacy is going to be first-class importance for Ethereum, I think it should be, then like, we need to have multiple paths toward continuing to make sure that we have it, right? And also, I mean, in general, I think, like, these things should be the responsibility of L1, right? I think we should not require individual, like, like identified actors, including builders or even including application developers, to be virtuous, right? And so we should really ensure censorship resistance of the L1, and also we should do a version of account abstraction that is friendly to privacy protocols. So 7701, for example, does this. And so that way, privacy pools and Railway and Stornado Cash will be able to get rid fully of the public broadcaster dependency.
Hey, so my question is, you showed a slide with a lot of things that could be paralized, the reads, the writes, etc. So were those use cases what you had in mind when Ethereum came out with Whisper? And if so, because you also said that off-chain is good because it doesn't leak as much metadata, is there a strong case for the adoption of off-chain peer-to-peer, like I'm going to say Waku, like Waku?
Yeah.
Would Waku make sense for a bunch of those?
Yes, so I think like Whisper and like Waku is a successor to Whisper, so Waku is very important work, and I know it's already starting to be used in messengers. These things are good. I think Waku actually is one of the things that we should explore for the privacy-preserving send RPC transaction use case. I do think that like Waku type things are insufficient in a couple of ways, and so like I think maybe 1 or 2 years ago the vision for how privacy would happen is basically you would have things like the Porto network, and so which would not just cover history, it would also cover state. And if you want to make a state read, then you would ask the peer-to-peer network and you connect to it through Waku, and then it would give you back a Merkle branch, right? The reason why I think this is insufficient is that I think anonymization is not enough, right? Basically, if you think about it, like let's say I do a Railway withdrawal and I withdraw into account X, right? And then right before I do this, there is in the network a query that goes to account X and also a query that goes to account Y, right? Then what's actually happened is, well, there is information that is out there in the public that linked X to Y. It actually doesn't even matter that theoretically X and Y might have been maps to different nodes, right? Because like even just those two accesses happening at the same time is still enough information to like probabilistically narrow that user down to a very small number of participants, right? So like I think for that reason, we don't just need anonymization, like we actually need a mechanism that allows users to do reads without those the content of the read, like the index or the address that you're reading, being exposed to anyone except for the user themselves. So I view those two technologies as being highly complementary for the Ethereum use case. Like I think for the sending transaction aspect, like mixnet type things, which includes Tor and I2P, which can also include Waku, is indispensable.
Also to talk about Waku again. Back in 2021, I built a messaging app that was on Waku. And one of the interesting things is that because the node was running in browser, I didn't have to require the user to do some operation to actually run a node. So what do you think about, because I'm running also an Ethereum node archive, and so I write my own Explorer, have my own RPC, which is self-hosted and private. But we have learned that people don't want to run their own node, so is there any way we could have something similar that says, in order to access the service, you have to, even without knowing it, run a node?
I mean, the challenge with the without knowing it part is that even a partial state node is going to take tens of gigabytes, and you can't like ask people to download tens of gigabytes in the background without telling them, because like at the very least it's going to like destroy a bunch of people's phone plans, right? So I think anything that is like seamless and fully in the background is something that realistically is just going to require some kind of like a light client-based approach. Now, what you could do potentially is you could have like an even more radical partial state node, like a node that only stores the state of like say a privacy protocol and nothing else, and so it's obvious to the network that you're a user of the privacy protocol, but they don't see anything else, right? And that's interesting. So that would be like one thing that I think is important to keep in mind. But I mean, in general, I mean, the other challenge, of course, of this kind of run a node without the user even knowing it is basically that then, like, if the ecosystem standardizes too much over that, then, like, users don't become aware of, like, what security guarantees they have. So the type of approach that I would favor is like a type of approach where, like, this is related to the whole problem of embedded wallets in general, right? Where, like, if you use an application with an embedded wallet, then by default, the embedded wallet does its thing. But also, if it detects that you have a browser wallet, then it automatically, switches over to the browser wallet, and then the browser wallet can run the checks itself and give you a guarantee that you're being secure, even if like the DApp interface has been hacked.
I was wondering about governance and privacy. I know you mentioned the on-chain voting as well as the fund transfers and kind of important privacy elements there. Are there any other specific use cases around governance that get you excited where you think it's crucial to enable privacy?
I mean, I think for me, like, governance is, it's like often one part voting and two parts communication, right? And so having privacy-preserving comms and having privacy-preserving comms with the level of UX quality that people are willing to actually adopt it and default to it is something that's very valuable. So, I mean, Signal, I think, has done quite a good job, but also, like, Signal definitely lags behind other apps on at least some dimensions. I mean, I know increasingly I've been seeing people migrating to Mattermost, which is like self-hosted over Slack, though, which is, like, I think fine for the context of an organization. For the context of something more diffuse like a DAO, like, you probably want people to be able to communicate in a way where the trust guarantee doesn't even depend on the operator. So having like something stronger and sort of even more cypherpunkish would actually help a lot. So that's one. And then for the voting part, I mean, I think like basically every part of a governance process should be ZK'd, right? And then like basically the principle is sort of only necessary transparency, right? So the rules of the game have to be transparent and have to be very clear to everyone. But in the context of the actions, like only the contents of the action that need to be public would be the contents of the action that actually get made public. Like we can think about that as a starting principle, and apply that across all the different regular DAO voting, quadratic funding, sortition, like any kind of designs. I mean, actually, sortition is interesting also, right? Because like you should be able to, like, you should have ZK sortition where nobody else knows if you've been chosen, right? Because if you have been chosen, that's like a very easy coercion vector, right? So, I think. Like we need to think like privacy first across all of these things.
Is there any work on reintroducing interfaces to allow for encryption decryption keys, which might be derived from a root key via a standardized API?
Interfaces, allowing interfaces. So is this like the equivalent of what MetaMask did back in the day with giving you like an encryption Yeah, I mean, I think this is a good idea. I think this needs to be, like, this is actually not too far from some ERCs that have already been made. Like, I think 5564 is the ERC for stealth addresses, and stealth addresses implicitly depend on a public key encryption technology, right? So if you generalize that only a little bit, then you can basically have a system where each account can publicly show like what its encryption key is, and then you'd be able to do encrypts to an account, and I think that would be super valuable.
Maybe as a follow-up, it would also be super cool to set a small, defined, restricted payload, which can be decrypted. Right? We don't need to make it big, like a very small interface, very clearly defined. To just send something in for encryption decryption.
Oh, I see. So you mean like the equivalent of a Zcash memo field? Yeah, I would support that.
Is Railgun ever going to lower their 0.25% fee? Do you know?
I mean, that's a question for them. I think, I mean, realistically, for higher levels of adoption, at some point they will have to. But no, I think this is their choice.
There's lots of
You would see that
private
business
projects like
yeah.
TIMECODES will help to onboard corporations. How do you see the synergy between B2B privacy and sort of like B2 human privacy? And where are the disconnects between them?
So I think they share a lot on technology, right? And like enterprise privacy projects and like kind of look, these sort of grassroots Ethereum ecosystem privacy projects have contributed to the same code on many occasions. Many of them are forks of each other. There's a lot of implicit collaboration at the tech level. Often, one thing that's happened in practice so far is that the B2B privacy use cases, they've decided that for their compliance needs, they have to have some kind of backdoor. Whereas I think for these kind of more consumer-oriented privacy protocols, like there's been a strong standard of them being backdoor free. And I mean, like, so things like privacy pools and Railgun that basically allow people to like publicly say, I am not like one of these depositors, like that's fine, right? But the thing that's not fine is a system where your privacy can retroactively be rug pulled, right? Like if you think you're private, you should stay private. And this kind of guarantee is incompatible with the kind of approach that B2B has been taken and like the B2B protocols compliance needs. So that's like probably the biggest disconnects that we've seen so far. I mean, my personal dream is, of course, that over time kind of norms keeps changing and the compliance needs on even the B2B side will start shifting toward more like a kind of privacy pools and Railgun style selective disclosure approach. But that's something that, of course, will continue taking time. But no, I mean, in general, I do see those ecosystems as being very collaborative, just because even if they make different decisions, they use like 90% of the same code.
What radical privacy? What is privacy endgame?
I mean, to me, privacy endgame is basically that, like, you should be able to have your digital life without revealing information to other people that you do not want to reveal or that you do not know you're revealing. So that's, I mean, like, I think privacy is also valuable in physical space, and like, I definitely do not appreciate all of the people that just like randomly, like photo me and then put me up on crypto Twitter, and then there's like people talking about like, oh, like this is what Vitalik is doing now, but unfortunately, those kinds of problems are kind of outside of our area of expertise to solve. No, I think like the domains that I think will matter over the next two decades, right? I think are like, especially as physical privacy keeps decreasing, digital privacy needs to keep increasing to compensate, and that, like, this involves privacy of communications, this involves privacy of funds transfers, this involves privacy of governance operations, and ultimately, like, those three things, they're not entirely separate categories, they're a continuum, right? Like, any funds transfer is at least in part a communication, and like any communication is at least in part a governance operation, right? But then other categories that will pop up, privacy of AI. So an AI is like increasingly becoming a sort of a second brain, and ChatGPT seeing all of that is something that should not happen. Who here has a local LLM installed on their devices now? You should. Who here has bought some kind of computer or GPU specifically to be able to run better local LLMs? Okay. One thing that you can do, by the way, that's like actually economically optimal is buy something powerful, but share it between you and a group of your friends, right? So like, for example, like if you look at a Mac Studio, with top-end specs, like the cost does go to the crazy side. It's $12,000, but the property that LLM use has is basically you're only actually using it like 1% of the time, right? And a full-size Mac Studio is actually powerful enough to run full-size DeepSeek at a very good speed. And so one thing you could do is, you could basically take one such device and basically give, yourself and a few or a dozen or a few dozen people that you reasonably trust access to it, right? So there's a lot, I think more experimentation with kind of local LLMs and even kind of going up to the larger models is a good thing. Basically because, the AI is going to become more and more a part of your thought. We're also going to start getting BCIs very soon, brain-computer interfaces, and so privacy of BCIs is literally privacy of your mind. Basically, privacy will go down a lot if we're not careful, and if we are careful and if we do the right thing, we can keep it at a similar level or even increased. And I think this is a very valuable project to push for.
Can you share the perception of Cypherpunk within 2 years? Because the first year, once you published the article, and I'm just checking the DEFCON talks, only Peter was bunking for and Center was the only one talking about this sector. Then some B2B companies were exploring how they can talk about this, but the legal would allow them to talk about. And what's the state of this cultural shift and change within the system?
Yeah, I think in general, kind of for the world, this is actually a very good political moment to start talking about cypherpunk and privacy topics more openly. And I think this is actually true for a couple of reasons, right? One of those reasons is that the global political environment is much more unfriendly than it was, more than 2 years ago, definitely more than 4 years ago, and like way more than 10 years ago. And so the idea that, you can just go run one of these centralized things and it's run by like nice idealistic tech people and like they're definitely not going to do anything bad or get captured by people who will make them do anything bad is just like more obviously completely false. And this is not something that like grassroots rebels care about. This is something that institutions care about. This is something that governments care about, right? And so that's like one thing, right? Basically, in this kind of like much less friendly and much more unstable environment, having more sovereignty over your own data at an individual level and at a group and community level is more important. And the other thing is that like there are people who have talked about the current era as being an era where you can just do things. And sometimes, of course, this is bad because just doing things sometimes involves just shooting missiles. But at the same time, from an individual point of view, like, you can just do things does mean, you can just go and make privacy protocols. You can just go and send people $10,000 without telling anyone. And like you can just like really go much further in asserting your digital rights than people were comfortable with a few years ago, right? And so I think there's like basically from both of those angles, right? Like the need has increased and the opportunity has increased, and supporting kind of personal and local community security and seeing privacy as being a core part of that security is something that is, I think, very important to, both talk about and make a reality right now.
Since it's very important for you to keep your thoughts private and you run a local LLM, how do you deal with your location privacy?
Yeah, currently not well, and currently, like I do not claim to have good solutions, right? And one of the challenges here, right, is that like even if you do, like burner phones and literally rotate them every month, like even a month of data is totally enough to uniquely fingerprint and identify you. So it's a hard problem, I think. If you want to like really go further out on location privacy, then like we will have to figure out kind of lifestyle alternatives to having your internet constantly with you on the go that provide something close to that level of quality. And like that basically means much more accessible mesh networks. That might even mean kind of more piratey stuff, like something that automatically connects to Wi-Fi networks and automatically does the click through and like, like it goes through passwords or whatever. Basically, generally, you need an alternative, some kind of alternative to that for connectivity is probably the number one thing. But then even kind of beyond beyond that, right? The other thing is just like the ease of in-person surveillance and just all of the cameras that are everywhere, right? And the more realistic thing to do is to just kind of continue to fight for laws that kind of restrict those kinds of things and put controls on them, right? Because like obviously, like people can get around them, but like every single one of those things does push the people creating the cameras to be more careful and to kind of not be as brazen in data collection or in letting the data get leaked. But going further beyond that, like I definitely admit it's a challenge.
What's your opinion on how privacy projects can reach product market fit? Because we're talking with folks on the scene, and only barely a few, for example, for Railgun, it took 3 years to hit the break-even, and barely any self-funded project of 2-3 people can reach this state. For Rodkey, it's based on the personality of let's say, and there's not many people like him. So how would you suggest privacy builders to go post-hackathon in their way to find that product market fit?
I think we should learn a lot from Signal, right? Signal is like the one reasonably cypherpunk project that like actually has gotten a huge amount of adoption to the point where famously even the U.S. government uses it. So that's Bitcoin. Well, Bitcoin. I would not call Bitcoin a privacy project, right? So I think. Look, we should and I think from my point of view, what succeeded with Signal is it actually does have a good enough UX that it's a kind of maybe 80 to 90% capable drop-in Skype or Telegram replacement, and then that's good enough to the point where basically you have these spikes of adoption that happen, Snowden revelations, and then the whole Pavel Durov situation last year, and basically every time this happens, more and more people become interested. But in order for that to happen, your project has to be ready for it, right? And so to me, one of the learnings is basically just improve UX, right? Though, at the same time, where even Signal is, it's definitely not strong enough on the metadata privacy, and so we do need to keep pushing harder there.
We just have a few minutes, and we'll run a hackathon, we present lots of ideas, and usually developers, when they do hackathons, sometimes they overscope what's possible within 3 days. What will be the low-hanging fruit in terms of dev hours spending to reach a certain privacy level?
Okay. So if you want to work on, for example, PIR, then one simple thing is instead of focusing on state, you focus on history. And the easy problem that you do is basically that the input is a log topic and the output is, and basically the client asks the server, give me what the one log in the previous block that that has that log topic, and then the server like scans over all of the logs in just that one block. So that's like a set of size 100 to like maybe between 100 and 1,000, and then replies back with that. Like if you just have that, like that already is the seed of privacy-preserving history query, and like that's a thing that I think especially in the GPT era, lots of people here are very able to go and vibe code. Well, or hopefully the like locally running DeepSeek like 0525 or like whatever the most recent one era. So then, if we're talking about like ease of use, then like build a wallet that like creates a one-click experience for privacy pools or railway operations. Then, if we're talking about like ZK voting, like actually fork one of the some like DAO like governance framework and like basically like rip out the backends and make it private and otherwise make it look as close to identical as possible, right? So like I think that's kind of roughly the bite-sized chunk you'd want to do for the hackathon.
Let's go to the last one.
What are your thoughts about whistleblowing rights and how they intersect with privacy data?
Yeah, I mean, in general, I think whistleblowing is absolutely important. I mean, I'm generally a big believer of Julian Assange's maxim of privacy for the weak and transparency for the powerful. And I generally think that like actively forcing powerful organizations, including companies, including governments, to be more open than they otherwise would be is like actually one of the more important counterforces to reduce the risk of like some kind of single actor dominating the world in some irreversible way in the future. So to me, whistleblowing is definitely an important part of that. I think one area where ZK Tech would help is it can actually make whistleblowing credible, right? Because not only can you reveal information, but you can reveal information attached to a zero-knowledge proof of the truth of that information.
What do you think about ZKTLS for that?
Yeah, ZKTLS is good. Yeah, you should use it.
Okay. Thanks, Vitalik, for
yes,
coming.
thank you too.